IMechE one. Yeah, it's a precedent we're enjoying setting, and yeah, keen to swap over as well if you've got things you want to share with us. Absolutely keen on that. A few plugs, Aaron, then I'll hand the floor over to Sam. In fact, you know what? No, I'll do this one. Sam, do you want to say a few things first, and then I'll come off towards the end, rather than it being too much of a back and forth. Sam's coming up. Yes, no shit.
Hello to everyone online. I want to extend the IMechE's thanks and the committee's thanks for actually inviting us and being part of this talk. Looking forward to it. As far as just centre notices, this is going to be our last one before our summer break. We'll be back in September with the Chair's Address, which will be in Darlington. And also we're part of NERF as well, which will also be in September. But keep an eye on social media posters. So,
October the 1st.
Yes, very early October.
was it October? Sorry, it's moved. Sorry, it's October. Thank you for that. Yeah, keep an eye on our social media and our websites, and obviously our emails as well. That's it.
Right, nice. Thanks, Sam. So, the first thing I'll do is just a reminder to everyone online, a bit of etiquette check. Please keep your microphones muted and your cameras off so that you don't become part of the eternally recorded sort of representation of the seminar in perpetuum. So thanks everyone. We've established sound levels are all right. The last thing is safety notices. Follow someone with a Network Rail lanyard who isn't me, and then we'll take you to the safe. It's at the front of the main front door. But basically, if you make sure you're with us if there's a fire alarm, there are a few people who work in this building, so they can make sure that you're out and safe. If there is a fire alarm, we're not obviously not expecting one. The only thing I'll say, I'll do a bit of calendar announcements at the end. I will just say before, just in case anyone runs off, Wednesday the 28th of May, we are planning, or not planning, there will be a visit to Gould Swingbridge with extremely limited numbers. Some ears just popped up. If you're keen to go and have a look at the Swingbridge before the works on it currently finish, then come and speak to me and I will record your name and we will make sure you're able to come and attend. That should be, I know it's short notice, but given numbers, I think there'll be some Wednesday the 28th of May. So Wednesday the 28th of May for those online, that should be a genuine, I'm not going to make the joke about riveting, but it will be a genuinely fascinating bit of a visit to some serious railway history in use today still. Right, before I continue waffling off forever, it is an absolute delight to have Colin Johnson up from D-Gauge, Managing Director for D-Gauge. Colin just made the joke to me, which is too good for me not to repeat to everyone, that he's probably the only second generation kind of gauging engineer, clearance engineer in the history of, maybe the history of the world, who knows? But it's an interesting, it is absolutely an interesting legacy, and I'm excited to, well, perhaps worryingly, give you the floor to talk about whatever you want for 45 minutes to an hour, because we kind of said, Colin, come and tell us what you think is interesting at the moment in your world, which maybe that was too broad a scope. So if anyone's got trains in 4 hours, yeah, no, Colin, absolute delight to have you. Thank you.
Thanks for the introduction. I suppose I just frame a bit about me. Not only second generation gauging engineer. David, I think, is in the audience somewhere. We've worked together for kind of 14 years, but I'm very proudly a mechanical engineer. So I got involved. My history before rail was in automotive, and before that aerospace. I think I've got a pretty good variety of kind of disciplines coming in. And before rail, did quite a lot of dynamics, and that kind of linked into the D in D-Gauge, which is dynamic gauging, and trying to think about all those kind of things. And there's often jokes of what the D stands for in D-Gauge. Some may think it stands for David, some may think it stands for dynamic. But the reality is that it's always changing. So I think the dynamic is the right way to think about it. And in pulling together this presentation, I was trying to think of things which are interesting in our world at the moment. Spans more than just the UK, so really quite interesting. And as we move into kind of the new control periods, what's really interesting is when I started engaging, we were talking about clearance in millimeters. That was the currency. How much space can we save? But now we're in a world where very much the currency is actual currency. So we shouldn't be talking about millimeters and changing gauges, how much space that gives us, but how much cost does that save? So I'm trying to put that lens on the types of things that we do. So without further ado, so a few things, I suppose, to give myself a bit of structure. Thanks. I want to start with the idea of what is the cost of doing it simply? So we all know in the UK we have a complex relationship with gauging, but what's the price of doing it simply? And is it too complicated? Now, I say that being a mechanical engineer who just loves complexity. So have we kind of written our own rules and we kind of endorse it because we like it? Should we use gauges at all? It's a really kind of polarizing question. I've got my own opinions, which I'll willingly share. They may not represent D-gauge all in there, but it's an interesting idea to think about. And I think the most startling thing is what should we expect in the future? Because gauges are a reflection of what we think is going to happen and to prepare for that. So the cost of simple gauging. This for the room is a European gauging set, and it's really simple. It's big enough to fit most things. It should be simple to design for. It's simple to design rolling stock. It's simple to design infrastructure right. But in the UK, it's difficult to fit. In lots of places, difficult to fit. Even in Europe, it's difficult to fit. It's difficult to board. We can even see from that picture how far away a train step would be. And so we asked the question that if the railways are here to serve people and those of difficult mobility, does this gauge actually serve what we're trying to do? And I think that we should be very proud of the history we have in the UK of actually striving for level access and level boarding. And all we have to see is pictures of the continent where that's not as well followed. It's future proof, right? There's no way we could ever need anything bigger than this single deck containerized freight system. Yeah. So again, the idea that we should start, we've already got this, we've already solved it. The Europeans have already come up with a simple gauge. I think is one where we have to scratch the surface a little bit differently. Spoiler, it isn't future proof, and we'll go into that a bit more. But I couldn't help but put forward some gauging truths, and this is from, I suppose, a decade of trying to answer them myself. Gauges will always be bigger than their component parts. There is no way that if we put two vehicles together, the individual vehicles will in any way be smaller. It's always going to create a bigger whole. And we're using gauges typically to make a collection of vehicles. And we then simplify it or shrink wrap it to make it easier for the designer, for the engineer to fit. It will always be bigger than the shape of its component parts. They always need to change with the requirements. And I know that this is a point of frustration for those who have to use gauges and not develop them, but there is a constant stream of new gauges often coming out of either the European standards, the Americans, the UK standards, but we have to change with the requirements of the industry. And so I couldn't help myself but go into some of the history of these, even for my own interest. The more we try and fit in a gauge, the more simplification the gauge has become. And I've used this example, which is the American double stack container gauge, which looks absolutely nothing like the vehicles which occupy the US railways. It gets more and more simplified, which means that we capture more and more space. We're moving a lot more fresh air. This is a mouthful. Better gauging reduces infrastructure costs, right? If we make it the fitment between strains and infrastructure better, it reduces the cost to fit it, but it makes it more difficult. It is more difficult for the vehicle builders. It's more difficult for the designers. It's more difficult for the maintainers. So we have to wrestle with that why can't we make it simple? Well, it's because we need the complexity to make sure the fitment is really, really close. And so that's the balance which we're always trying to make. And I suppose to exemplify that, I've tried to look at this in terms of some really high level costs, and we'll have to use our good old friend AI to help us kind of get some ideas of what some of these things we're contending with. So what if we turn the UK into a brand new UIC railway? What if we just said, okay, we're going to just start again. We're going to build everything. Whenever there's a new project, we're just going to build it UIC principles, which from UIC, that means that we can buy standard equipment. It means we can buy standard rolling stock. It means that we can take a lot of standardized approaches. Well, look, if we take the east-west pricing, which at its non-electrified pricing space, and scale that up, we're talking between 400 and 500 billion pounds to make our railway compliant, if that was the word. But of course, with that, we get all the requirements. Of course, we have one or two trains lying around. 15, I think, what's the last count? 15,107 carriages, which we would have to replace between freight and passenger and all those kind of things. So we've got a bill of 45 to 55 billion in rolling stock that we're going to also have to replace to apply simple principles. Now, we know those simple principles means that we get lots of benefits. We repeat standard rolling stock. We also get a brand new railway, which increases the asset life. However, it is not a trivial sum of money, and certainly not a sum money which this government or future governments, I think, are going to invest in horse scale. So, is it too complicated? Have we just simply made it too complicated? Can we keep with what the UK rules are doing, but actually just simplify it to make it more straightforward for us to apply? So, I'm only gone back as far as 1994. Now, many of the gauges which we're still working to go back to 1961, which go back to 1921. I can't go back that far. Now, there may be some people who will happily correct me on that, but there's some really, really important things that happened in 1994, which changes the way we do gauging. No, it wasn't PlayStations and Dookie. Like they were great things. Now these what was interesting in my life in 1994. But these were the gauges which we tended to work with. We were trying to keep it quite simple. We had a passenger gauge, we had a freight gauge, we had a loco gauge. Now, the really interesting thing is in the published standard in 1994, this is how it was presented. So we weren't even consistent in how we documented our gauging. We had different diagrams, statements, all this. But it was really simple, right? Back in 1961 onward, 1994, we had really simple gauges, straightforward. But going back to the requirements, we couldn't really envisage many different requirements in terms of length or things like bogey spacings and all those kind of things. It was all based on 20-metre architecture and 40-metre bogey centres, plus or minus the conversion into the imperial. That was the form of our rule. So we had a really relatively simple rule set, right? Only 3 gauges to work with. Wow, really? Because then we also had W6A, and I couldn't help but go into the history of what the A stood for in W6A. Anyone know what the A stands for? W6A?
Was it third rail?
Yeah, it was so I thought A's were to do with additions. No, this A was to do with exceptions, to exclude the shoe gear area and that kind of thing. So that's why we had W6A. It's this tiny little notch area down here, W6A. But then we had W6A exceptions for containers as well. So we started to have it. Now, anyone familiar with these this is W7. So we started to have the foresight for what we need in terms of containerized freight, which was really okay. So we know we need to adapt the gauges. And again, we didn't think about naming. So we've got W6A, we've got long, we've got words, and all these kind of things. But let me to think what drove this complexity. And my only conclusion is our requirements consistently changed all the way through the 70s, all the way up to where we are now. And I suppose I looked at that in terms of, well, what are the key things? Well, standardized shipping containers. And I used my favorite word in this is this, the inverted commas, because until I got involved in gauging, I didn't realize there were so many permutations of standard shipping containers. It's absolutely incredible. And we don't even cover in our rules really the permutations of length, which is a really fascinating side. So we had to then have the complexity was from the shipping. We then had novel passenger vehicle designs. And I say that knowing that I don't think the UK have, in really recent times, had some novel trains in, but we've actually excluded some of the really novel stuff. And I say that if you look to some of the Spanish builds, the Talgos with the single wheel, single axle kind of, there is some really radical stuff out there, which we're quite lucky we don't have to consider in our standards. Track access and track friendly bogies. We implemented an idea that we're going to use better bogies to dissipate the energy instead of putting it into the tracks, but we're converting that into movement. We're simply going to dissipate the energy by moving the vehicles, and that it means that our bogies are swaying. We had new computer simulation, so we had to move away. Well, we moved away from the drawing board, and in doing so, that kind of coincides with the uptake in survey technology. In the 90s and the noughties, there's a huge uptake in using laser and LiDAR technology to try and monitor our network. And then European TSIs. Now, that darkened my day in the form of electrification projects. TSIs. So the technical standards for interoperability. And we were working on projects like the Great Western, where we're trying to make a European compliant railway where there's no way that we're going to be able to have European compliant rolling stock. So we ended up trying to build things which were much bigger than would ever be utilised. So I wanted to put forward my understanding of standard sizes, and I think this might be quite interesting for anyone who ever is involved in freight projects to understand what drives some requirements. When I started, the logic was, well, you fit W12 everywhere. So W12 was the logic of the single biggest envelope we had. And that was, and so you had this idea that that was the only gauge you went for. But what I was interested in is why we have such a mix over the network of different routes and compatibilities. And you can see from the heights that what we've done over the years is we've adapted and tried to see forward of the shipping community demands, of the ISO community demands, of what are we trying to move off the boats onto the rail. That's when you got the heights and so you go from the 8 foot to the 9'6" super cubes. From a width perspective, we're again going into the ranges of the idea that you've got the insulated containers and the refrigerated containers and all these kind of things. And alongside and throughout, I suppose, a 20-year period, not only did the number of gauges increase, but also what they included. So W9, we're including SWAT bodies and a lot of those types of shapes. W13, if anyone ever was around when that was being done, the idea of piggyback wagons that we could accommodate. And then W12 also took the idea of let's try and predict what the suspension is going to be doing. And so we ended up with a lot of wagons and a lot of suspensions, which never really materialized, but they were nevertheless included in standards. So, and it turned out that they were some of these wagons were very expensive to build. So in doing so, they were just not preferred. And it's that balance of when we changed the track access, so we changed the wagons rolling stock. So I thought it's an interesting side to see of how the development of these gauges have moved over the side. And I also thought it's quite interesting to show how bad we have been at predicting where we're going, because you only have to look now. When we came up with the notion of this, it was a 40-foot long container. And so we had wagons which could take 40 foots and then maybe 20 foots and have good efficiency, good utilization of the trains. But now when we're in the world of looking at 45-foot containers or 25-foot containers and all these permutations, so we changed the economics of the railway. But again, that's not reflected. So I think all those involved with developing the gauges did a really good job of trying to see into the future, but we have to respect that maybe that we didn't quite get it right. I'm fascinated by the term A, because exclusions and additions. So we now, if you could times the complexity of the shapes by the complexity about what's in it. So again, we have A gauges now. These are a relative. W6A is a relative new addition. Sorry, is an existing addition. But all the other ones, you can see that we have as we've updated the way in which we understand how these wagons and things have moved, so we can update the dynamics. The whole purpose is the history has told us whenever we have remodeled vehicles to understand how they move dynamically, so they have taken up less space. We have managed to make it more accurate, and that normally gives more space. There's, of course, exceptions to that rule, but the vast majority of the time that's the case. So that's what we have done with W7, W8. W10A, I think, is widely seen as a very successful gauge because it includes lots of the popular new suspensions which are coming onto the network, while still being able to use a lot of containerized freight. So now there seems to be a big push for either W12 or W10A. I think it's going to be a very popular gauge going forward. But again, includes some complex dynamics. And then we talk about novel passenger vehicles. And I think this is something which has caught a lot of the gauging and vehicle instruction community off guard. C1 is a relatively straightforward shape. And you can see that it has a lot of history with, it has a lot of commonality with what we're now talking in terms of, we call it PG1, passenger gauge one. And then, of course, that's a 20-meter vehicle. So we started to help the vehicle manufacturers by creating adjusted versions for 23 meters and 26-meter vehicles. Now, the irony being that we created the PG3 gauge came out after the Hitachi 26-meter vehicle came out. So we again couldn't quite see the requirements. But again, the aspiration is there. But the interesting thing is here that we have created, we're creating shapes to help people introduce different types of length vehicles on the network. But there's something, but we're having all sorts of novel vehicles which make it very complex furthermore. If we look at the Stadler, the picture in the Stadler, we can start to see some of these areas. We've got it's a common to very small sections, very small intermediate cars, bridge cars. They do some weird and wonderful things. We also have, with the Stadlers, we change the rules on nose overhang, which means that we actually change things like switch and crossing parameters and settings. And furthermore, our gauges, whilst they're not, they seem to be complex, they do sometimes miss some fundamentals, which are, we describe how they should happen on constant curve. We describe how they are on straights, but we don't describe how they move on transitional curves. So we are in a situation where some of these weird and wonderful architectures being described by the vehicle manufacturers don't quite fit despite our standards. So there is argument to make our gauges even more complex to define how they should go over transitional curves or reverse curves or over tight switches and crossings. I'm not advocating that. I'm just saying there is still cautions that just because we apply these, there's gaps. But some really interesting developments from these new manufacturers. And I anecdotally, I think that many of the manufacturers can offer you a vehicle in basically any permutation from 26 meters down as low as you go. They're the platforms themselves are so flexible. So I'm really interested to understand where these requirements go, and it'd be really interesting to understand from anyone in the audience from that kind of architecture background how we think that our standards may have to change to adapt to what the vehicle community is thinking. Electrification and TSI. So I started engaging not on rolling stock but on pantograph gauges, and that was because when I started, David gave me a British Rail book. I can't remember what colour it was, but I'm sure I had a proof title, the green book, and all these gauges and shapes. And I'd just come off a project to help Siemens introduce the Thameslink vehicle with super high definition models, very accurate dynamics, really good survey data. And then we were given these shapes on the left. And so that's what we're doing for pantographs. And so we ended up going through the process of saying, well, a pantograph should be treated like a vehicle, but it's got just another element. It's got another element of variability of how the pantograph head relates to the wire and relates to the vehicle position. So thus, we set about with RSSB to do quite a lot of pantograph research, 20 odd years. And in doing so, we've managed to create some gauges which respect the European ways of doing things, which means that the heads roll and adapt to the pantograph wires, but they're still fundamentally the British rail shapes. They're still fundamentally the pantographs which are used on the railway. We're not accommodating the European shapes and heads, and we're not taking into account things like isolation horns and all those kind of things. But it's another area of complexity. So when we talk about there's a big driver for, I think, a lot of the design community say, can we have one shape? Can we have one shape which takes into account freight, passenger, and electrification, whilst giving us good accessibility? You could start to see some of the complexities we're trying to do. And then we get the super. Now, this is the kind of thing that obviously, as a gauging engineer, we kind of love in writing the technology. But David reminded me of the different generations, and so the terminology which we've been used. So we've got A's and we've got issues and all these kind of things. We've now got generations. So we've got the idea that a first generation gauge is something where, well, it's static. The shape doesn't change as to the dynamics which affect on the vehicle. Now that might be that we have included a level of fat. We may have included 8 inches around the vehicle for that. But it doesn't adjust, it doesn't change. And then we go to the second generation, and anyone who dealt with W12 gauges when they came out, it was almost like a lookup, like you had one of 5,000 shapes that you could apply depending on what the track was doing, and it was kind of a good approximation. And that was we call that, it had full dynamics involved, but it still wasn't quite there. And then we have third generation, which is, well, it's entirely variable. The manufacturer has given us enough information for us to be able to look at the local situations and rotate and move it accordingly. And most of the times that's come from the likes of multi-body simulation, Vampire, Simpac, all those kind of things. But you can apply it to any shape, you can apply it to any vehicle. And that is the way in which the railway the UK railway uses it commonplace, but interesting terminology. And of course, then we have the things like the tilting trains, which are even more complex because you've got not only the forces acting on the train, which cause it to do something, but you've got the reaction to the forces, which cause an alternate rotation, for example. So you have all these weird and wonderful interactions, which the vehicle manufacturers are happy to state because it makes their vehicle more compliant. So what does that cost? Well, I tried to put forward, like, what does it really cost for us to get good models? Because that's Network Rail and most infrastructure managers around the world have cracked the idea of very good survey data, and they've got their monitoring fleets and they've got all the systems going around because that is collecting LiDAR, all those things. So on the assumption that we already have all that survey data, what we need is good vehicle data. That's really what the cost is driving us. And I love this picture because I think that we still strive to do a lot of this already in terms of static sway testing to understand when we twist a vehicle, how it responds to the force. But ultimately, to do what we're doing now, we've got specialist software. That's in terms of either gauging or it's in terms of multi-body simulation. So there is some deep down costs involved in doing it. But it's mainstream, I would go as far as saying. There are many people offering many solutions in that space. We've got vehicle testing and modeling. So that's the idea that we can make these models, but somehow we need to validate them and prove that they're right. Again, very conscious, Gareth, that you're in front of me with a test track remit on, but understanding how our models reflect reality is something which we have to do. Commonly not done in the UK, I think it's fair to say, in terms of dynamics, but definitely we should strive to understand the inertia, the roll, the ride, all those qualities. And it's not just for gauging. We need to understand this for track force. We need to understand this for track damage. We need to understand this for derailment. It's part of the ecosystem. But typically, depending on how novel the vehicle is, anywhere up to 250k for testing. And if you wanted to scan a full train, it's off-the-shelf technology. I would say within the next few generations of iPhone, you will be able to scan the external envelope of a gauging train of a train for gauging purposes with reasonable accuracy. You're trying to find the lumps, the bumps, the things which stick out. So that the price of that type of technology is really coming down. And alongside that, the UK got some great experience. We're really good at fitting trains on routes where they shouldn't have fit. And it's really interesting. Network Rail Consultancy are doing a lot to educate the world that there's expertise in the UK. RSSB have some really great engineers who've been around the standards long enough to be able to point me in the right direction at the very least. So I suppose what I'm trying to put here is the cost of the complexity isn't high compared to the cost of simple gauging. That's the kind of the starting of the that part. And I wanted to maybe talk about some of the benefits. Smaller envelopes being smaller, more close. And this, as a picture, is a 946 container on an FEA wagon. So a common Super Cube container on a really common wagon. On a tunnel which is not gauge compliant for that combination. So when we're trying to support this intermodal shift of getting freight onto the railway, I genuinely think that this is a viable way of us looking and investigating. If we want to if we want to increase the gauge of a full route, of course we need big investment and it could take a long time to do it, but there is the opportunity to sneak it through. And we've been doing this for decades with passenger rolling stock. It's the same principles. And you can see the level of detail, which is quite easy to achieve. Good resolution of the wagons. We commonly rely on W6A in the bottom, but we know it's not very, very friendly gauge to maintain to. And York Station is a classic where it's exceedingly tight. But most of these wagons are a lot smaller than the W6A envelopes. It also allows us to do some advanced techniques. And the first one I want to put on is transitional curve assessment. Transitional curves are the bane of a huge amount of stations where we have a lot of these problems. I'm going to say stations like Ely, Scarborough, York, Newcastle. I mean, the list goes on. There's a handful of problem stations, and they tend to stem from some form of transitional, really tight curvature. When we're working with gauges, it's very difficult for us to understand how that transitional behaviour is, because the manufacturer can put any type of architecture into it. It could be a number of different wagons with a number of different permutations. When we're assessing the wagons, we can assess that going over a transition very, very accurately. And again, the more accuracy tends to give more space. So one of the advanced techniques is actually modelling vehicles going on transitional curves. And I think we're doing quite a lot of work with Network Rail to improve that. So interested to work more on any tight transitional places. Probabilistic gauging, there's been many different presentations in the ether about what that is. It is a way of us modelling to a more statistical valid way. The output of that gives us a chance of strike without me jumping around my slides too much. Probabilistic gauging gives an engineer an indication of how close is. We all know situations where vehicles are not gauge compliant, but there is anecdotal experience that it's been down there or it could go down there. I see lots of nodding around the room. We've all seen or heard of a load which has gone down. Probabilistic gauging is kind of the analysis which demonstrates why that happens and to what level of safe that will be. Very useful in the future for derogation to help understand those mitigating cases. It's widely used now for electrification, but I do acknowledge that electrification has a slightly different risk appetite. You're working with risks of trips, not risks of arc, not risks of strike. But again, lots of good work being done by Network Rail to understand whether you can understand how close something is. The reason that's important is because you can't do that with gauges. Gauges are a fixed envelope which anyone can build anything and make it compliant to. It has to be a vehicle for us to be able to consider it, probability. And of course, with advanced design, I think there's a big call for the community to say, okay, we just want a few gauges to design to, but we are predominantly a passenger network. And Birmingham New Street, we already have to design against 53 different types of passenger rolling stock. So therefore, the idea that we need to maybe design instead of against 53 to 153 is a computer exercise. It's not an actual, it doesn't change our process. So I'd say that we can absolutely utilize the power of computing there. And it does give us a better understanding of risk. I've got to put a question to Steve Valentine, who's already challenged me to check that I'm right in this. But the reality is, I would wonder whether Network Rail have a more competent design for derogation of a tight clearance to a vehicle design which has been modelled to a few millimeters accurate, as opposed to just a generic envelope which could be anything. My experience is if we have good accurate models, it allows engineers to make engineering-based decisions. So that's my opinion on it is that we can get a much better understanding of risk, and that could help with derogations, which should be used if we can't design for everything. The cost benefit. So we were asked from, I think maybe the word is think tank. There's obviously a lot of work happening in and around Manchester with the moves of the depots and etc. So we were asked to understand what it would be to enhance a route to get W10A compliance, i.e. high cube containers. Relatively short route, I think about 30-ish miles. And so we developed, we talked about Innovate UK before. One of the projects we worked with Innovate UK was to turn a clearance into a cost. So that, for example, if you had a tight clearance for an X percentage of a platform, how much would Network Rail budget in their business cases for it? So we went through quite a cost of taking Network Rail units and then so we've got an inflation linked cost calculator, which basically says if we had to make all this normal clearance, what would be the cost? And so for W10A, it's 92 million. It's a sizable cost for us to get containerized traffic on the route. But we can sneak vehicles through. We can sneak containers through on some wagons, on some conversations, and it's upwards of 4 million. Now I say upwards because when we start sneaking things through, we start to apply for tight clearances and we start to consider operational restrictions, all things which are possible in vehicles and not on gauges. So the point being is, I think that there is, in this current climate, when we're trying to make benefits now to the industry and open up routes for more traffic, looking at not just complex gauging, but actual vehicle models can really provide us some cost benefit analysis. But at the very least, we've got an ability now to turn route clearance into costs now with some feasibilities. I'm going to finish off. I think I'm all right for time. My conclusions, and I'll say this, that they don't reflect my employer, because some of them might be a bit contentious. Gauging is always going to lack the requirements. So it's interesting. I was speaking to someone in the standards community, and they're like, "Oh, we've done gauging enough for the time being. We've got to keep it consistent for the next few years to not confuse the audience." And my thought is, our requirements aren't going anywhere. We're getting more and more complex. So maybe that's not true. And history has shown that it's been very difficult to predict requirements, even with some of the great people helping us in the like from economists to vehicle designers. So we're always going to be lagging. It's very, very difficult to mix passenger and freight shapes. And I say this knowing that it's probably, there is a political strategic element to it, which is well above mine and probably many people's pay grades. But we have to respect that they require very, very different things from the railways. And I'm quite lucky that that I work with quite a few networks around the world, and those who have the most gauge-friendly networks are those who completely segregate the two requirements. And you only have to look at London Underground compared to what in terms of what they're able to do in mobility and access and all those kind of things. It's not Network Rail's fault, but I think there is one thing that we as an organisation need a really clear remit about what is the biggest driver and thing for it, and then combine that obviously with electrification that we've got to take this to account, but they are very different shapes. The complexity cost of what we're doing engaging is insignificant compared to infrastructure. So I know, whilst I know that the design community, of which I can see many common names on the chat, would love us to have a singular shape, I think that we'll move the world, the UK world, into an unaffordable space. And I would argue one which is less passenger friendly. The only real options are to move the passenger. Our main problems are bridges and platforms, and the only way to really improve platforms is to move them further away, which makes our boarding worse. So wouldn't surprise me to say, for petition for better assessment and more models. But it is insignificant compared to the infrastructure costs. Individual models are a better use of space. So I know that often we go down a very much, shall we change the gauges? To change a gauge is upwards of 3 years of consultation, and then we've got to implement it, and then we've got to use it. If we really want to get new things on our network, we have to do individual models. And the passenger vehicle community has proven that. We've introduced, I think, upwards of 10 new shapes over the last control period in terms of flirts, and from the CAFs, the CAFs, the Alstoms, all sorts. It is, I would argue, a simpler route, and it will work for freight as well. I can't see why it wouldn't work for freight. I think often when I speak to NetRail and UK engineers, we're kind of envious of the European positions of saying, oh, it's so much easier on the continent. That's an on-track TGV tilting train. They are using the UK dynamic principles to introduce high-speed train on conventional low-speed traffic. So I want to try and maybe flip it, that actually we should see ourselves as pioneers, and actually the rest of the world is kind of watching what we're doing and copying it. And that's interesting. That's in a world of the US is seen to have lots of space, but actually they don't. They have the same kind of rules that we have. They have 12 inches of clearance, but as soon as they exceed that 12 inches by 1/8 of an inch, they have to start making mitigations of things. And dynamic gauging is of real interest to them. So I would put it that networks around the world are starting to adopt the UK techniques because it's a proven technology, it's a proven way forward, and they're outgrowing their historical gauges. And that's a really dramatic pause for I should have probably closed it better than that. There we are, 45 minutes, I think.
Beautiful. Well, which is good, which leaves us plenty of time for questions. So I'll throw it to the floor, and that includes everyone in there. In fact, Steve's already getting stuck in. Steve, we'll start with you actually. Steve Ballantyne asking, there is also a cost to track maintenance engineer for increased structure gauge monitoring, and this is never factored into project costs when proposing reduced clearances. Absolutely. And yeah, Steve is pointing out, by using a standard suite of gauges, it gives the freight industry assurance of long-term clearances, whereas it's far more difficult to manage clearances to various individual vehicle container profiles. Colin, thoughts upon that?
I would welcome a UK strategy which said we are going to make, say, W12 or W10A clearances like over all network ride routes or key corridors and all things. So I'm not petitioning for not having gauges, if that's a terrible sentence, isn't it? I suppose it's that, but the fact is that with the absence of big investment to say we're going to clear corridors, that there is there are alternatives. But yeah, I think that when we're building a new railway, we should absolutely build to what we see as the future requirements. But then we have to look at to the East West Railway of not building a railway with electrification, and and I'm actually not sure what gauge that we're building HS2 to, in terms of, are we looking at double deck containerized freight, or etc. etc. That all those kind of things I think goes into the mix. But yeah, we should strive to go for some of the gate, when we're building a project from scratch, or we're doing a huge enhancements to try and go for the full Monty. But yes, I'll go back.
Sure. Louise question, and then I'll go back to Steve.
How hard is it to build a vehicle model? So some of the photos, it had like a train in a lab. Is it quite an onerous process, or is it actually, with the technology we've got, vampire modelling and all sorts, can we? Is it sort of like 10 grand to produce a vehicle model, 50 grand, 100 grand? Is it?
So the biggest challenge is physical validation. And so what I understand, I'm sure that we've got we work quite closely with the Appium's Realis team, with their vampire team, some great experts there. And they've got a lot of historical validation evidence. And so if we're looking at something which is commonplace, often we don't even need to do physical sway testing. There's enough empirical evidence in the past of validating models so that we can reuse and do that. I would go as far as saying it's not onerous. Sometimes we have to capture data, but we know what data we're going to capture. We've recently supported Network Rail with the modelling of some locos for those kind of things. I think in terms of time, it could be anything from a month to maybe 6 months to do it. And the cost, I think, is often down to those who run the trains. So that's where the real cost is. So if Network Rail can run their trains and capture some data to validate the model, fantastic. It's a well-trodden path, and I think there is a big there's a big community of experts who can do it, and I know at least of a dozen engineers who I know have gone through that modelling process and could do it. So
That's that was my personal experience. I was back of the room supporting me with the project. We found it immensely difficult. We was trying to, Network Rail's rules are such that they prefer force gauging rather than comparative gauging. Is that a fair assumption? No.
Yes, I mean, comparative gauging is a very it is easy, but you also have to make sure that you're comparing apples with apples. So I think there's
Network Rail forced me on this particular project, absolutely. And then they're trying to introduce a modified 20-year-old vehicle, and finding data of the suspension characteristics was nigh on impossible.
Yeah.
In fact, with one particular vehicle, we tried to carry something, and I was forced to change the project direction completely. One particular vehicle, spent 10 grand of aborted money, or found out it wasn't possible in one particular.
Yes, I think pre-1990s is always tough to find that level of data. I think anything onwards from that, yes, there is it can be a challenge.
The other thing that we managed to do as well, which you mentioned sway tests, and that seems to be the go-to validation tool, is very costly, 50 grand upwards. We managed to do a delta Q of the Q test, which is a fifth of the price, 10,000 pounds, and that was found to be satisfactory with wagon type vehicles that don't have airbags and a much simpler, predictable suspension system. But yeah, it was finding data.
Yes,
it was a 6-month exercise, doing some string data, suspension data, wheel data, axle data, bearing clearance. It was horrendous. It was horrendous.
The absolute issue to try and get similar to what Colin just presented, was to try and be more space accurate in modelling as well. And it was another work. I think you agree that they were originally looking at introducing that vehicle W16, which has got upwards of 10,000 restrictions, and the vehicle that we finished modelling is about 200.
Yeah. Yeah.
It was recently.
But the benefits of doing it, obviously beneficial. I think that's the balance. Yes.
It was an amazing result. Painful.
Steve,
Yeah, I'm a retired Voltop engineer. I found it particularly fascinating because I was involved in the gauging for the network fleet in the late 80s on the southeastern. And the southeastern around the Greenwich area is one of the most tight gauge areas you obviously know. One thing that caused problems then, and I haven't heard you mention, was the civil engineer just would not guarantee his track would stay in the same place. And I forget the figure, we had to allow 10 to 15 millimetre, because the track might be here one day, and he proved a case like it was slate being curved. It had moved within weeks of him resetting it. It was well known that the original slam door trains, they would touch going into Cannon Street if things weren't quite right, which they track out.
Tactile gauging, yeah. Tactile gauging, that.
Yeah. But the prize was being able to have coaches wide enough for 2+3 seating. It was basically the same as the old C1, but we used dynamic modelling, and there were quite long stretches where there were 20-mile-an-hour speed limits simply to reduce the sway of vehicles. I think is it Blackheath Tunnel around the Greenwich area, and as far as I know, they're still there. But is this civil engineers? I mean, I know that's pretty expensive. Is it still a problem with ballasted track, or have they found ways of being able to make the track stay the same so you can get containers on the bridges and so on?
I can answer this one if you want.
I'm gonna say that I am a mechanical engineer, and I know there's a lot of civils who may chat me. So yeah, please do.
in a room of PWI.
Yeah, exactly. Yeah.
Positions, and this is something which the West Coast implemented, not under the name absolute flat geometry. So it's basically a way of reinstating track's original design position every time you camp, so that you're confident you've got the clearance in tilting trains. So on other regions, Eastern being one of them, there are areas which will become managed track position. There's different levels depending on how important it is to keep track in the same position. But that is, we're moving towards that.
So how physically is that done on the ground?
In terms of, well, it's you reinstate the track. You go into camp, you make sure you tamp it to the design position every time. And then for certain sites where it's really critical, so mostly for we've got type certification clearances, you have to go and validate it on a certain frequency to make sure your track's not moving too much. But that is not implemented yet, but it's definitely sort of imminent.
So it's not a physical constraint, is it?
Not a very, yeah, right. Yeah, so
It's the cost of, it's the challenge. The cost of that is either in guaranteeing that the infrastructure will be where it says it will be, the rails will be where they say they'll be. And that's through the fact that you have to maintain it more, or indeed maintenance is specifically more expensive because you might have to remove ballast to put the track down where it should be, rather than just adding ballast and getting your line level, which is cost implication. And if we're in a situation now where government's said, oh, we don't care about railways anymore, so we're not going to fund them as well, that increases or reduces the reliability of the railway with the maintenance pressures. So then that goes back to, well, it's difficult for us to put the track back in the perfect location. So yeah, anyway, it's gone discursive. But, yeah.
I mean, if you come back to the idea of dynamic gauging, we took the principle that we understand the force on the vehicle, and the forces mean that's how much it sways. We were involved in the tram train project, which was quite interesting because the tram aspects of that build specified at certain stations what their fixity would be, and it was less than Network Rail fixity. It brought in this concept that you could have a local fixity to the local requirements, and so and I know that there is ideas within the Net Rail community that we can have a more specific movement fixity or movement tolerance to what we know. Now that might be it's managed, it might be because the alignment itself, a straight platform, a straight constrained platform, simply may not move to the allowances and the standards. I think we're moving into a world where we need to collect the data frequently enough to prove it's in the right place. It kind of maybe ties into the IM strategy of how we collect data and alignments. But from a technology perspective, yeah, absolutely. We should be able to, if we know that that track does or doesn't move, we should be able to state that in the assessment and then reflect that in clearance.
Steve's got some thoughts on that, and then I'll go back to David's question. Daniel's question online. Steve says, I got lots of overtime through the Networker project working for Southern Track Renewals. Since then, we've had ballast gluing, lateral resistance plates, to name a couple of methods. To add to that, on that point, I think working with Steve and with Tim, I was the first in a project I was doing as a designer, the first to use lateral resistance plates to justify a different fixity of the track, which was kind of an interesting project. That was for a horribly overcanted curve through a bridge. So there are things that infrastructure can do that can be quite interesting. Daniel has an interesting question, which is relating to what you just mentioned about tram train. What measures do you think tram train schemes should implement to ensure level access in line with ARVAR in terms of gauging?
Cool, blimey. So
no pressure.
No pressure. What do you think the tram train schemes should implement? I presume we're talking about things like level access and
so ARVAR is basically about providing level access to boarding, among other things. But we on the main line claim grandfather rights and exclude a huge number of people accordingly. More on that later.
Well, I don't know. I think that what we're doing is we're putting in yet another requirement into a gauging mix of a much smaller trade and trying to get the compliance. I don't really know the answer, I'm afraid, Daniel, on that. But again, I'm trying to align myself on what we're doing around the Sheffield kind of region with that kind of project. I'll have to come back to you. It's a good question.
Any other questions in the room?
Where we've got older vehicles that are owned by needs to do gauges. Who should pay for a fleet when you if you're introducing a new vehicle that's gauging? Who should pay for that gauging exercise when you might have a dozen vehicles, but the whole railway community will benefit? To me, it seems fair that simple local projects.
Are we talking in terms of, say, like, I know, Class 43, where we've got 10 different people who own them all over, and then the benefits of that?
Yeah, that's a good example. Yes.
We've seen it in the past where there's a number of people who use it who've come together to get a better gauging model. I've seen it in the past where Roscoe's have done it because it's obviously in their interest to help with their cascading. Yeah, absolutely. So I don't think it's that. I think it's really those who could have the benefit from the additional usage. Plant's a really interesting one, I think, because you're going to have many people who are going to continue. Many beneficiaries of it. I know the experience we've had is you kind of look at the ownership diagram and say you've got 20% of them, you got 20% of them. Could have benefit, but yeah, there's two difficult parts: who pays and also who owns the resultant data as well.
Should the industry release what's good?
I think that at the very least it should be sat within, like with the Roscoe's have the design history and the design changes that fleet throughout their life. I think that there is argument to say that they should at least have a copy so that it's available. Sharing for the industry again is I can see why that's. There are those who are going to want to benefit from a competitive advantage because they've got half a fleet and they know how it moves. But I haven't. I'll be honest. I don't. We haven't tended to see that behaviour. I don't know if others in the room have. Most people have a shared goods, and if two parties want that data, there's normally some form of commercial agreement. But I do think it should that by default, Roscoe's who own the fleets should also have a copy of gauging envelopes to make it at least easier.
Any other questions in the room or online? Steve's very pleased. He says thanks for a great presentation, but we're not quite wrapping up. If there are any other questions, I think I have one now actually. I just quite enjoyed myself. An hour of gauging all Tuesday. No, well, in which case, so without there being further questions, I'll just say a couple of things. Actually, you know what, Sam, are you wanting to do anything to close out before I say it? Okay, in which case, I'll firstly say I really enjoyed that. I'm extremely pleased. I mean, firstly, I'm extremely pleased to understand our gauging, but I'm extremely pleased that you started pretty rapidly. You mentioned accessibility, which is something that I think there have been pockets of success, and we're getting much better at it. The phrase that you used a paragraph later, level boarding, is now in the vernacular as a co-founder of the campaign for level boarding, something I'm extremely passionate about. It's now in the vernacular, which is really good. You know, Stadler arguably pushing us much further forwards in that sense than anyone else. The thing that for me, the A on the gauge is I always think that's the whoops letter. It just means whoops. Just swap the letter A for whoops. So it's W6 whoops because we forgot something on it, which is always fun. As a designer, I spent 10 years never used. Well, okay, some of that they didn't exist, but I've never used a PG gauge as a designer, and I don't think they should exist. There's no point. The amount of energy that went into developing them, they're a waste of time. Just get rid of them. People who are gauging engineers on that side of things, Steve and Karen, you might disagree with that, but I just don't see the point in them. I've never used them as a designer. I just think they're a waste. Just delete them. They're a waste of the RSSB's time and yours and ours. Not necessarily true for free, for the reasons that Steve laid out. I think there's a different story there. But equally, anyway. The point being that I think that was an extremely interesting tour. I was thinking, well, you know, is this going to be too detailed? But actually, it was a really nice broad discussion of gauging for anyone who doesn't know what the hell any of that means. But really nicely detailed for the people. There's plenty of detail in there for the rest of us weirdos. So that was extremely good, Colin. Thank you so much. Dan, I'll have to you, and then I'll just close.
Let you go first because that gave me enough time to get us set.
Yeah.
On behalf of, well, I suppose all of us, but the IMechE North East, I'd just like to thank you for your talk. Just present you with that. That's very much. That's good. Thank you.
Oh, now we feel I've done. We don't know. That's right. Yes, right. Okay. Well, right. That's just not going to stand out.
All right.
Well, excellent. I'm very pleased. Okay, we need to get the IMechE in on all of our talk. Excellent. Now, just a reminder for anyone who's interested in going to see Gould Swingbridge, that's Wednesday, the 28th of May. The next stuff, I have to get my calendar. What is the next? What is it? May. The next PWI presentation will be in a month, actually. It will be in here in a month. Thursday of the month. I think there isn't any. I think we're back in here again. Louise is about to present on that one because I cleverly forgot to put that up. The calendars are all online and you should be getting prompt emails. And the last thing I wanted to say was re-emphasis on vice chair positions for particularly Leeds and or West Yorkshire and South Yorkshire. For us to continue offering a diverse calendar in terms of geography, we need your involvement. So please do get involved. Other than that, it is next month. Yeah, perfect. So the next one, yes, it's in fact it's an ASPRO conversation. It's encouraging investment whilst assuring safety, asset protection, which that's a very pertinent one for the conversation we've just had. Everyone, thanks so much for those who've been online. Really good to see you on here. Everyone, thank you so much. And again, Colin, thank you so much.